Hi, welcome to EE662 Distribution Systems Engineering. Starting from today, we will discuss about the substation. Okay? So, talking about the substations, I think in the introductory session also I have mentioned you briefly about the substations and their different configurations. So, I will briefly go through that section in this couple of slides. Okay, so in the substations you have the in here the primary incoming lines, and then you have the ground wire which is connected to the ground. Okay, and then you have these overhead lines, and you have different transformers for measurement. So you have the current transformers, voltage transformers. So basically these four we call them CTs and PTs for measurements. And then you have the disconnect switch. Okay, and then you have number 6 here, you have the circuit breaker, and then number 7 is the current transformer. You basically use to measure the current. And then you have the number 8 at here, the lightning arresters. Okay, and then you have the main transformer of the substation, which basically either convert the voltage or regulate the voltage depending on the requirement, or depending on the substation type. And then you have the control building in the substation, which basically do the monitoring and control of the substation. And then you have the outgoing secondary power line. Okay, so I think this arrangement we have also discussed under the introductory session. And then we also talk about the different types of substations. So you have this outdoor type with air insulated equipment, indoor type with air insulated equipment, outdoor type with gas insulation, indoor type with gas insulated equipment, and the mixed technology about on this air insulated and gas insulated equipment. And then you have the mobile substation. So sometimes when the substation is out of service, in order to maintain the uninterrupted power supply, so these mobile substations are used. So I'm not going to go through these substation types. So we discussed about the different substation types like single bus arrangement, and then double breaker arrangement, main and transfer bus arrangement, double bus single breaker arrangement, ring bus arrangement, breaker and half arrangement, and so on. So if you want, you have all the description here as well, since I have discussed them in the introductory session. I'm not going to go through it again. Okay, so today we are going to look at the high voltage switching equipment. Okay, so we will take different equipments one by one, and then we will discuss. Okay, so these switching equipments are basically used to provide the isolation. Okay, or so we can categorize them as the no load switching and the load switching. So in the no load switching, which including the line charging, current interrupting, loop splitting, and magnetizing current interrupting. Okay, so these are not designed for, these equipments are not designed to switch the load current. Okay, so when we discuss about different equipment, you will understand what's the difference. And then there are equipment which can switch the load current, and there are equipment that basically interrupts the fault current, which is much higher than the load current. Okay, and so the specifications of these equipments are basically the magnitude of the load current and the magnitude of the fault current. So depending on the type of equipment you use, there are maybe different specification, but this load current and the fault current are the couple of main specifications that specify the characteristic of the switch. Okay, okay, so first we will talk about the disconnect switches, or what we also call the isolator. Okay, So these are the mechanical devices that conduct electrical current and provide an open point in a circuit for isolation of one of the following devices. So these disconnect devices are basically used to isolate some other devices. For an example, devices like circuit breakers, circuit switches, and the power transformers, capacitor banks, reactors, other substation equipment. So in order to isolate this equipment, maybe in order to do a maintenance, or maybe in a fault situation, in order to clear the fault, so the substation use these disconnect switches. Okay, so the function of the disconnect switch is to open and close reliably when called to operate. Okay, so it should be reliably open and close when required. Okay, and it should carry the load current continuously without overheating. So that means whenever the system is connected and the load current is flowing, so that current will also flow through this disconnect switch, so it should be able to continuously handle this load current. Okay, to remain in the closed operation position under fault current condition. So under the fault current condition, this is not the one that breaks the fault current, so it should remain open, remain in the operation position. That means at the closed position under fault current condition. So then the circuit breaker will break the fault current, and then you can the substation maintenance or operator can disconnect the isolation switch in order to do the fault clearance. Okay. Okay, so but in the normal condition and under the fault condition, this should be in the closed position. Okay. So this is normally used to provide a point of visual isolation of the substation equipment for maintenance. So as I said, so this is not for breaking a short circuit current or any type of fault current or a load current. So this is basically to provide the visual isolation. So once this is open, you can visually see that it's open, and then the whoever going to do the maintenance know that that part of the substation is open without any issue. So he can perform the maintenance without any fear. Okay, so the thing is like if you have a circuit breakers, so you can't see whether it's open or closed because it is something inside a container. So it's whether it's open or closed, you can't visually see that. But when you do open a disconnector or the isolator, you can visually see it. So you know that that part of the substation is isolated. Okay. Okay. So these are some isolated. So I am not going to play all these videos because this is also a recorded video. So I will anyway upload the PPT of this one instead of the PDF. So you can play these videos and see. So I will
That was cool.
So this is another. How an isolator works. So this opening and closing could be, we will talk about that either mechanical or either manually operated or automated. So so this okay, let's continue our discussion on the disconnect switch or the isolators. So these are designed to continuously carry load current. Okay, so these are designed to continuously carry load current, as I said earlier, and momentarily carry short circuit current for a specified duration. So it can also carry a fault current for a specified duration without get damaged. Okay? And so this is designed for no load switching. Okay? So these are not to be open under loading for any reason. So these are designed for no load switching. So the load has to be disconnected through a circuit breaker or by some other means before you open the isolator. Okay? And you have also seen in the video as well, they are relatively slow speed operating devices. So they are not designed to open suddenly for a any current or anything, any fault or anything. So they are slowly operating devices. Okay. So and they are not also designed to open any significant magnitude current up. Okay. So they are not defined built for large current isolation. Okay. So and they also use something called the interlocking equipment. Okay. So these are available to prevent operating sequence errors. For an example, if you remember, we had a recent blackouts couple of I think months ago. So with the blackout happens in the entire country. Okay. So this was because the not following the proper sequence of the operation. So that was one of the reasons for the blackout. But so in order to prevent such type of things, there are these interlocking equipments available with this disconnect switch. So for an example, this interlocking equipment, they inhibiting the operation of the disconnect switch until the load current has been interrupted by the appropriate equipment. So this interlocking mechanism makes sure that this switch will not be opened until the load is broke by some other equipment like a circuit breaker. Okay. And the same thing about the grounding as well. So this recent blackout, there was a problem with the grounding while uh, the the system was put back in. Okay. So that was the issue. So if you had these proper interlocking equipment and if you use them properly, then this connection of isolators are not allowed until the ground connection is clear. Okay. So such type of things are done by using this interlocking equipment. Okay. So there are different types of interlocking equipments associated with these isolators. So the first type is shown in here. It's called the mechanical cam action type. Okay. So this basically prevents the disconnect switch from being closed when the grounding blades are closed and vice versa. Okay. So when the grounding blades are closed, that means the system is connected to the ground. So when the system is connected to the ground, you are not allowed to close the isolator. So you have to disconnect the system from the ground and then close the isolator. So what happens here is when you do the maintenance, you open the isolators, and in order to make sure that any remaining current in the system, to eliminate any remaining current in the system, you ground the system, okay, through this grounding blade. Okay. And then then you do the maintenance, and then once you do that, you have to remove this grounding, and then only you close these isolators. Otherwise there will be a short circuit happening to the ground. So this mechanical cam type interlock equipment make sure that this will not happen. Okay. Okay, so then there's the other type called the key type, so which you can see in here. And so in this type of interlocking, it's disconnect switch and it's integral grounding blade. Okay. So it interlocks the disconnect switch and integral grounding blade, the same thing, but so it's also used for interlocking a disconnect with a circuit breaker. Okay. So for these two type of interlocking, these key type interlocking devices are used. And you also have this solenoid type interlocking devices. So what you can see in here, so inside this box, what you have is the solenoid. Okay, so this is used to ensure that the circuit breaker is open before the disconnect switch is allowed to open. Okay, so you make sure that the circuit breaker is open before the isolator is open. So you have these interlocking mechanisms which are very important in order to maintain the operation sequence. Okay. Okay. So these disconnectors, so they can be operated in different mechanisms, as I said earlier. So there are manual operation as well as the motorized operation. Okay. So in the manual operation, you have this swing handle, okay, operation, which basically used to disconnect the switches rated 69 kV or below, or carries the current of 1200 ampere or below. Okay, so and you use this gear crank type operation mechanism in order to disconnect the device, the isolators, which carries the current of 1600 ampere or more, or with the rated voltage of 115 kilovolt or more. Okay, and the motorized operations are used to remotely operate these isolators by using a SCADA system or any other remotely operated system. Okay. Okay, so this is a small video on a 500 kV motor operated opens and close the disconnect switch. Okay. Okay, so we can categorize this disconnect switch based on the mounted positions. So depending on the substation size, the available land area, you will use the different types of the mounting positions in order to save the ground land and the area used by these devices. Okay, so there are three types of mounting positions. One is called the horizontal upright, so which you can see in here, which basically opens upward in here like this. Okay, and then the other one is the vertical, so which you can see here. It's mounted in this way, so it's vertically. So you can see these two insulators are there, and then you have this disconnect switch. You have a couple of them, and then so they are basically operate in this way. Okay, open. Okay, so and then you have this underhang type disconnect switch, which are basically hanging in a bar like this. So you can see that that's why it's called the underhanging or underhang type disconnect switch. Okay. So again, this we can further categorize this disconnect switch based on the operation. Okay. So this operation could be vertical or horizontal operating the switch blade. So these are the switch blades. So they can operate horizontally, or they can operate vertically, upward or downward, and horizontally into the this. I can't draw it in here. You can see that into the this my computer screen, or out of my computer screen like that. Okay. Okay, so based on this operation, you have different types of these isolators, okay, in the substation. So you have the vertical brake disconnect switch, shown in here. Okay, so which basically breaks vertically upward, right? And then you have the double lane brake disconnect switch, which basically brake from the two ends. Okay, so I have some videos, as well as you can find many videos in the YouTube. So just search double lane breaker and how it works. You can see how the brakes are opening and closing. Okay, and then you have this double lane brake V type disconnect switch. So you can see, like let me see whether I have yeah, so I have a description, so I will just show you the visuals of this and photos of this, and then we will talk about this operation in little bit more details later. Okay, so you keep in mind the shape, and you know what's the ground clearance you need. For an example, for this one you need a bigger ground area for this to establish. Okay, but for this one you don't need that much of ground area. So if for a small substation you can use this type of device. Okay, and then you have the center brake disconnect switch, which basically brake from the center. Okay, and you have this center brake V type disconnect switch, which basically brake from the center, right, at this point. Okay, and then you have the single side breaker and the vertical reach disconnect switch, and the grounding switch are there, as well as the hook stick operated disconnect switch. So you might have seen this alongside the transformers in the road, the distribution transformers. So on top of the distribution transformer you have this hook stick operated disconnect switch, which basically disconnect when you want to do the maintenance of the transformer. Okay, so you might have seen these. So if you don't, alongside the roads you can find many distribution transformers, so you can have a careful you can have a good look on them, and you will see these uh, hook stick operated disconnect switch. Okay, okay, so let's take a look at them one by one. So you have the vertical brake switches. So these are the ones most widely used disconnected switches. So they can be installed on minimum phase spacing. That means so you have, unfortunately today with this PowerPoint I can't draw, but you have these three phases. Okay, sorry, you have three phases, phase A, B and C. So with this type you need the minimum distance between phases, because it's operate vertically upward. Okay, so let me see whether I have a type. So the one that you have seen at the very beginning, yeah, this one is this way, not toward the other phase. Okay, uh, and so these are excellent for installations or in high fault current locations due to their contact design. So you can see this is the contact of this vertical brake switch. So because of this contact design, so they are very suitable for high fault current locations, because this contact can also handle very high fault current. Okay, and then the other one is the double end brake switch. I think this one, let me see again. So that's the double end breaker switch. Okay, so you can see, you have seen that with this double end breaker switch, because it's operate horizontally, you need larger spacing between the two phases compared to the vertical brake switch. Okay, so okay, so this can be installed in minimum overhead clearance location. Okay, so minimum overhead clearance locations, because it's not opening vertically, it's opening horizontally. Okay, so these are excellent for installations in high fault current locations due to their contact design. So these are also better for the high fault current location. Okay, so they are able to interrupt significantly more line charging current or magnetizing current compared to the vertical brake switch. Okay. And then you have this double end V type switches. So let me see. Here. Give you give more detail on how these things. We go through this video later on. Okay. So the double end brake V switch is one of these. So this same thing like this, but these insulators are arranged in a V type mechanism, and then you can see that the ground needed to install this type of isolators are less compared to the other one. Okay, so it share all the same characteristic as the double end breaker switch. Okay, and it consumes the smallest amount of substation space of any three-phase switch type. Okay, substation space means the ground space needed for installing this device. Okay, so as they can install in single horizontal beam structure as shown in here. Okay, so then you have the center brake switches. Okay, so so they can installed in minimum overhead clearance location. Okay, and it required greater phase spacing, and it require only 6 insulator per 3-phase switch. Okay, so but you need 9 for the others, but for this center brake switches you require only 6 insulators per 3-phase system. Okay, so here you need 9, so for each phase you need 1, 2, 3 insulators. Okay, and for 3 phases you need 9, but in here you need only 2 insulators because it's operating in the center, opening from the center, so you need only 2, and so per phase. Okay, let me see whether I have a video switch. Okay, so we call the center
scared to death.
Whenever you're ready.
Go. Other way, other way, other way, other way. There you go.
and this one also. See clearly that only 2 insulators are needed for each phase. Okay, okay, so center brake switch, and so then you have the center brake V type switch as you have seen previously. So it's all the same characteristic as the conventional center brake switch, and it consumes the smaller amount of substation space. So now you know why. Okay, and then you have the single side brake switch, so can be installed in a minimum overhead clearance. Okay, so it's and may require greater phase spacing. Require only 6 insulator per 3-phase switch. So single side breaker. So I don't know whether I have I don't have, did I had one earlier? This one is double in type. Maybe at the other way. Maybe at the very beginning. I can't even remember what were the videos. Okay, anyway, so these are, so you can easily find a video on the YouTube to see that this single side breaker, so how it operates. Okay, so it's so you operate, you open it from a one side. Okay, so again you need 6 insulator for the 3-phase. That means 2 insulators per phase, so you have 1, 2, and then the connection is between those two, and it operates from the one end. Okay, so it's single side breaker, so only the one side is broke. Okay, so since it is operating horizontally, you don't need much overhead clearance, and it may require greater phase spacing because it's operating vertically toward another phase, so you have to have a gap between two phases. Okay, and then you have the vertical reach switches, so used most commonly in extra high voltage applications, typically for 345 kV, 500 kV, and 765 kV installation. Okay, so these are fairly common in Europe and in the other parts of the world as well. Okay, okay, so we have watched this, and then with the disconnect switches, the isolators, there is another important switch called the grounding switches. Okay, so these ground switches, so they can be furnished as an integral attachment to any of the previously mentioned disconnected switch. So this ground link switch is an integrated part of a disconnected switch. So they both goes together, as I explained earlier. Okay, so they can be furnished as a standalone devices as well. Okay, so they perform the safety grounding or disconnect switches, buses and capacitor banks. So these grounding switches are basically to ground these disconnect switches or bus bars or any capacitor banks when required for the maintenance. Okay, so and then as we discussed earlier, the interlocking mechanisms can be used or normally employed to assure that proper sequence of the operation. So all the grounding switches use the interlocking mechanism with whatever the thing it is connected, maybe for the isolator or maybe for the bus bar. So to make sure that the proper sequence is followed in when operating. Okay, so then the other type of isolators are these hook stick switches, so which we have shown here. So these are basically a single phase device that provide the isolation, then can also provide the bypassing, typically for a regulator, reclosure or current transformer. So it can act as a bypassing device as well, and the transferring, so for feeding a load from an alternative source. So when you do want to do the transferring, feeding the source from the alternative source, you can also use this hook stick switches. Okay, and for grounding as well. Okay, so it's they can be used in many applications. So depending on how you have installed them and how you have configured them. Uh, so so one of the application, as I discussed earlier, is the distributed transformer. So to isolate the distributed transformers, you use this hook stick switch. Okay. So then the operator comes and put the hook into this ring and then pull down, so it will be open. Okay. And when you want to close it, you do the other way around. Okay. Okay, so that's about the disconnect switches. So next we need to talk about the load break switch, and then we will continue on that part. So I will pause this video for this one, and then we will continue with the load break switches.